Welcome children. Moving forward with the topic relations and functions, today we will define what a relation is. Now it is very much like the term defined in languages, the term relation. That means you're trying to relate two things using certain condition. Okay, so because in the previous chapter we learned a lot about sets, we will see how the elements of one set can be related to the elements of other set. For doing so, some connection is to be defined from one set to the other set so that the elements can be related to each other. So defining relations, let A and B be any two non-empty sets, then any subset of A cross B is called a relation from A to B. Now when we define Cartesian product A cross B without any restriction or condition, we pair all the elements of A with the elements of B. So the pairing does not take place under certain condition. But when we define a relation, we will be pairing after defining that particular relation how one element is to be related with the other element. Okay, so I have taken one example. Suppose A is having elements A comma B and B has got only one element, that is X. Then A cross B will be all possible pairs which we can have. A comma X, it can be B comma X as well. But if I have to define relation from A to B, it may happen that the relation is defined in such a way so that you are only getting one pair, or you are only getting other pair, or maybe you are getting both the pairs also. It is also possible that none of the pair is obtained. Okay, so I'll quickly give you an example. If we take two sections of class 11, suppose section A is having 10 students and section B is having 5 students. Say boys of section A and boys of section B. If I ask you to team up the students of section A with the students of section B, then you can pair according to your convenience any two. But within this, if I say the pairing is to be done keeping in mind that the boy in section A is brother of the boy in section B, then what will happen? Maybe you will not find any such pair, or maybe you will be able to locate some pairs satisfying this condition. So when we take Cartesian product, there is no condition and we are able to write all the possible pairs. But the moment we define a relation, we are able to get some pairs, or maybe no pairs we will get, or maybe we will get all the pairs. So anything is possible. Okay. Now for this example, as A cross B is having two pairs here, the number of subsets of A cross B will be 2 to the power 2, that is 4. So one can be null set, one can be the set containing A comma X, another containing B comma X, and the last one containing the entire A cross B. Okay, now depending upon in relation which subsets I am going to get or which possible pairs we are going to get, the relation can be defined in certain manner. Now if R is a relation from A to B such that R is equal to 5. So just now I gave you an example. Suppose when you are pairing or you are making a team of boys from section A to section B using the condition is brother of, maybe none of the boy in section A is brother of any boy in section B. Then the relation will become a null set because you are not getting any pair. In that case, R becomes an empty relation. Okay, maybe for the same example, you are able to get two pairs. There are two boys in section A who have got siblings, brothers in section B. So you are getting two pairs only, and then R will become a proper subset of A cross B, because if you are defining Cartesian product means pairing of boys from section A to section B, then any one can be paired with other. Okay, but satisfying this relation is brother of, there will be, suppose there are only two pairs, then R becomes its subset. So R can be a null set. It depends how the relation is defined. R can be a proper subset of A cross B. It is also possible that R is having all the pairs given in A cross B. That is how it is defined. And R becomes equal to A cross B. Then R will be a universal relation. So the way relation is defined, the result may vary from one condition to other. Maybe it is defined in such a way that you are getting null set, or it is defined in such a way that you are getting the entire Cartesian product, or maybe it is defined in such a way that you are getting some pairs from A cross B. So what happens in general, we can say that R is a subset of A cross B. I am not saying proper subset. Maybe the relation is defined in such a way that it is equal to A cross B also. This will include null set also, because we know null set is subset of every set. Okay. So in general, if you see, relation is a subset of Cartesian product A cross B. So what all ordered pairs will come in A cross B? Sum of the ordered pairs from A cross B, that will come in the relation. And as I told you, the number of subsets of A cross B you will get in R, that will depend upon how the relation is defined. Now coming to some more terms related to relation. You have seen relation is a set which will contain ordered pairs like this. Okay. So when we define domain of a relation, suppose A and B are two sets and R is a relation defined from set A to set B. Okay, then the set of all first elements of the ordered pairs that belong to R will be domain. Okay, come to this example. R is containing two ordered pairs. So if I have to define domain of this, then it will be a set which will contain only the first elements. The first elements are A and B. So the set containing A, B will be the domain of relation. So what we have to do, we will define R. We will write down all the ordered pairs in the relation, and we will write a set of first elements of each ordered pair separately. That will be the domain of relation. Now then comes range. Range is the set of all second elements of the ordered pairs that belong to R. The way domain contains the first elements of the ordered pairs, range will contain the second elements of the ordered pairs. So for this relation, if I have to define range, it will be a set containing only X. Okay. So then is codomain. Again, if relation is defined from A to B, then the entire set B is codomain of R. So the second set is the codomain. I'll just make a figure here to make you understand. Say this is set A and this is set B, and I start pairing the elements like this. Okay, so you can see at some places only one element is pairing with one. In this part, if you see, two elements are pairing with same element. Okay, so this is how, if the ordered pairs you are getting, and say this is also paired with this, I have got one pair, one element left here. So what are the pairs? You can name them also. Say this is 1, 2, 3, 4 and 5. This is A, B, C and D. So what will be the pairs in relation? It will be 1, A, 2, A, 3, B, 4, C, 5, C. So in all these pairs, the first elements are 1, 2, 3, 4, 5. So the set containing 1, 2, 3, 4, 5 will be the domain. And where are they paired? The second elements in the pair are only A, B and C. So the range will be the set containing A, B and C. But when we talk about the codomain, codomain is the entire second set. So if I have to define codomain for this, it will be a set containing A, B, C, D. So what do you see? Range is actually subset of codomain. We can write here, we can add this. Range is a subset of codomain. You will see, again, I have not written proper subset. Okay, because it may happen that all the elements are getting paired. Maybe one more 5 is again paired with D. So there is scope that every element becomes the second element of some of the pair. So there is a possibility range can be equal to codomain, but it can be a proper subset as well. Then talking about inverse of a relation, if R is a relation from A to B, then inverse will be from B to A. It is denoted with R with a superscript -1. And if R is from A to B, as I told you, inverse will be from B to A. And how are we going to define it? If A comma B belongs to R, then its inverse will be B comma A. That will be the element of R inverse, where B will belong to the set B and A will belong to the set A. So the position of the elements in the ordered pair is going to change. Now coming to number of relations, we can define if the relation is defined from A to B. Suppose we are taking R as a relation from A to B and say number of elements in A are P, number of elements in B are Q. So how many elements in A cross B? A cross B will have number of elements is equal to P into Q. You can see here A is having 2 elements, B is having only 1. So A cross B is having number of elements equal to 2 into 1, which is 2 only. So if A is having P elements, B is having Q elements, then A cross B will have number of elements equal to PQ. Now once you know how many elements are there in A cross B, we can tell the total number of subsets we will have in A cross B. Total number of subsets will be 2 to the power PQ. Now see how this is related to the number of relations from A to B. Again go by this. If you go through these 3 conditions, we said R can be a null set, which will be a subset of A cross B. Maybe R is a proper subset of A cross B, or it is equal to A cross B. So that means whatever number of subsets you have in A cross B, those many relations you can define from A to B.